Hey kids, today we're going to cover Module 4, Lesson 15, the slope of a non-vertical line. Take 10 silent seconds to make sure you can find this paper in your packet and then make these notes at the top of your paper. Module 4 is all about linear equations and their graphs. There are several equations and two variables that we will explore, but one thing that all of these equations have in common is their shape. Their shape will make a line. Remember, L-I-N-E, line are the first four letters of the word linear equation. It's important to note some things about two lines that you're familiar with from the past. All right, vertical lines. Vertical lines are straight up and down. Vertical lines are similar to the y-axis on a graph. Vertical lines are represented by the equation x equals c, where c is some constant or some number. That means no matter what our y values are, x will always be the same consistent and constant number. Likewise with the horizontal lines run left and right like the x-axis. Horizontal lines are represented by the equation y equals c, okay, where c is some constant, some number. Regardless of what our x values are, y will always be the same. We are going to uncover or unfold four key topics throughout topic B. The first key point we're going to discover today in lesson 15, and that key point is that a number must be defined for non-vertical or non-horizontal lines that are going to help us measure the steepness or the slant of that line. When we're talking about the steepness or the slant of a line, that number that we're measuring is called the slope of the line. Slope is a very important word that's going to be used all throughout 8th grade for the remainder of the year and all throughout Algebra 1. Slope is going to be later referred to as the rate of change, and specifically in Module 5, the rate of change of a function. Rate of change is terminology that you're going to use in later lessons. And our first exposure with rate of change or slope is figuring out the steepness or that slant of a line. In this lesson, you're going to make observations about the steepness of a line. You're going to be able to give directions about how to get from one point on the line to another point on that line. And that's going to lead us to make some conclusions about the ratios formed moving from one point or another, and compare the steepness or the flatness of lines. The second point we're going to cover in topic B, is that any 2 points on a non-vertical line can be used to find the slope of the line. The third key point is that it must be shown that the line joining 2 points on a graph of a linear equation of the form y equals mx plus b has the slope of m. So I'm going to zoom in on that equation as I say it. When we're starting to discover the lines of the graphs, they are all going to take this form, y equals mx plus b, where m is the variable that represents slope. So throughout this lesson, we're going to refer to m as slope. Then our fourth key point is that there is only one line that can pass through a given point with a given slope. Let's take a look at opening exercise. In our opening exercise, we have two graphs, graph A and graph B. Examine each paragraph and answer the questions with me. Which graph looks steeper? So examine graph A and graph B and write your answer below using the given sentence stem. Which graph looks steeper? It's also okay if you don't understand what the word steepness means. Write the directions that explain how to get from this point to this point in graph A. And write the directions that explain how to get from this point to this point in graph B. Please be sure to use the directions up and down, left and right. Write your directions from part B as ratios and then compare the ratios. How does this relate to which graph was steeper in part A? All right, it should look like that graph B is steeper. Graph B is steeper. And for graph A, we want to move up 2 units. 1, 2, and to the right 1, 2, 3 units. To get to the next point. For graph B, we want to move up 1, 2, 3, 4 units. And we want to move right 1, 2, 3 units. When I write my directions for graph A as a ratio, here remember ratios can be written in 3 forms. We want to specifically use fraction form. So I'm going to put graph A ratios in 1 fraction and graph B ratios in another fraction. And for graph A, I want to move up 2 units and to the right 3 units. For graph B, I want to move up 4 units. I'm going to put that number in my numerator. I want to move to the right 3 units and put that number in my denominator. I can now use these fractions, these ratios, to compare the graphs to actually determine which graph is steeper. The steeper graph will have the greater ratio. You're correct. Graph B is the greater ratio. It's steeper than graph A. Therefore, graph A is less than graph B. Remember, when our inequality symbol faces to the left, it can unfold to make an L or less than. Take a look at next pair. We're about to go through a couple of different examples. The same questions are going to be asked, and you're going to need to move in the same format. If you have any questions, just go back and rewatch anything. So examining graphs A and B again, which graph appears steeper? It looks like graph A is steeper. Write the directions that explain how to move from one point on the graph to the other for both graph A and graph B. So for graph A, I want to move up 4 units, and I want to move to the right 5 units to get to the next point. For graph B, zoom out, make my points a little darker. For graph B, I want to move up 1 unit, and I want to move to the right. Looks like I'm going to have to go a little further. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I want to move up 1 to the right 12. Question C, write the directions for part B as ratios and compare the ratios. How does this relate to which graph was steeper in part A? Graph A was steeper and had the greater ratio. Let's move on to pair B. Sorry, pair number 2. For imperative, I'm given same things, graph A and graph B. Which graph is steeper, graph A or graph B? It looks like graph A is steeper. Write the directions that explain how to move from one point on the graph for both graph A and graph B. In graph A, I want to move 7 units up and 1 unit to the right. In graph B, making my points darker. In graph B, I want to move 3 units up and 6 units to the right. Write the directions from part B. So for graph A, we said 7 units up. For graph A, we said 7 units up, 1 unit right. And graph B, we said 3 units up and 6 units right. Let's take these numbers now and write them as a ratio in part C. How does this relate to which graph was steeper in part A? When I write 7 over 1 as a ratio, and I write 3 over 6 as a ratio, and I compare these numbers, I know that I'm comparing 7 to 1/2. Okay, I'm going to simplify both of these fractions, 7 to 1/2. Which is greater? 7 is greater than 1/2. Graph A was steeper because it has the greater ratio. So already in the first 2 examples, we can begin to make make a conjecture about steepness or slope. The greater the slope, the steeper the line. The smaller the slope, the flatter the line. All right. For pair 3, pair 4, going to move a little quicker. So I'm just going to ask the 3 questions, and then I want you to answer them into the questions that pop up. Which graph is steeper, graph A or graph B? Write the directions that explain how to move from one point to the other on graph A and graph B. Write the directions from part B as a ratio and compare the ratios. How does this relate to which graph was steeper in part A? Which graph is steeper? Should have said that graph B is steeper. And for graph A, you want to move 1 unit up and 5 units right. All right. And for graph B, you want to move 4 units up and 1 unit right. 4 units up, 1 unit right. When I take these numbers that are in my underlines and I make them into my ratio, so I have 1 over 5 compared to 4 over 1. I want to know, how do these numbers compare? How does 1/5 compare to 4 divided by 1? How does 1 over 5 compare to 4? 1 over 5 is less than 4 over 1. Therefore, graph B is steeper. And has a greater ratio. Pair number 4. Which graph is steeper, graph A or graph B? I kind of can't tell. They look about the same steepness. Write the directions that explain how to move from one point to the other on graph A and graph B. When I'm looking at graph A, clear the screen up for you, and I make my points a little darker, it looks like I want to move 1, 2, 3, 4 points up and 1, 2, 3, 4 points right. So 4 units up and 4 units right. Bring that down at the bottom. I also want to be consistent and use the word units. Extra traveling on the graph, and each line represents a unit. I'm talking about graph B now. I want to move from one point to the other. Then I move 1, 2, 3 units up and 1, 2, 3 units right. Part C. Write the directions from part B as ratios and then compare those ratios. How does this relate to which graph was steeper in part A? 4 over 4 compared to 3 over 3. What do we know about fractions that look like this? A number divided by itself. Yeah, we know that those simplify to 1. So I have 4 over 4, which reduces to 1, being compared to 3 over 3, which reduces to 1. How do we compare those numbers? Is 1 greater than 1? Is 1 less than 1? Or is 1 equal to 1? 1 is equal to 1. So what would that tell us about their steepness? They have equal ratios, so they have equal steepness. That means that they're going to have the exact same slope, even though they're different lines. They're going to have the same steepness. Good job on your examples. When we put off horizontal lines to the side for a moment, there are 2 other types of non-vertical lines. And I'm showing you these examples right here on our paper. Those are going to be the lines that are left to right inclining and the lines that are left to right declining. Line 1 is going to represent the lines that are left to right inclining, and line 2 is going to represent the lines that are left to right declining. We want to talk about the steepness of these lines without any numbers being present, and we want to make sure that out of this discovery that we're able to say that a horizontal line, so a line that's just going straight left to right and not inclining or declining, actually has a slope of 0. So that would mean 0 steepness, 0 slant. It would actually be flat. We're going to begin by saying that lines that are left to right inclining are going to be considered positive slopes, and lines that are left to right declining are going to represent negative slopes, going to represent negative slopes. All right, let's start to talk about how to find the slope of left to right inclining and left to right declining lines. Here you've been given the line that has the point P and the point R on the line. Hold on a second, close the door again. Sorry about that. I want to know, in just like the previous examples, how do I get from point P to point R using the line as a tool? So I want to go up 1 unit, 2 units. All right, so I want to go up 2 units. And I want to move now to the right 1 unit because I see clearly that P is at 1, and -1 and 0. So for me to move back over to point Q, okay, which is going to be here at the origin 0, 0, I need to move 1 unit over to the right. So I'm going to move right 1 unit. Okay, like the previous examples, I want to take my change, okay, my up, my change in my Y, and I want to put that over my change in my X's, okay, my left or right, 1, which is going to leave my slope to be 2. So the slope of this line is 2, or that M equals 2. Remember we said in the first lesson that we want to use slope with the variable M. Take a look at another example. Take a look at another example. So our lines are looking a little different, but still you're being given a line that have the points P and the points R on the line, and we're being asked, what is the slope of this line? I want to know what is the directional change for me to get from point P to point R? Okay, well, my directions are going to be a little different. I'm going to need to actually go down 1, 2, 3 units. So I'm going to go down 3 units. Shift over so you can see that. So I've gone down 3 units, and now I want to move from here until I'm directly at point R. Point R is on the y-axis, so I'm just going to need to move 1 to the right. So I need to move right 1 unit. All right, so I want to now use my change from one point to the other to write my ratio of my slope. So I needed to move down 1 unit. Notice in the previous example when I moved up 1 unit, all right, I put a positive 2 in my numerator, but because I'm moving down 1 unit, I'm actually going to put a -3 in my numerator. And then I want to move to the right 1 unit. I want to move to the right 1 unit, so I'm going to put a 1 in my denominator. Okay, well, I'm going to use this number now to write my ratio for slope. So slope is equal to M equals -3. All right, and this looks just like those lines at the beginning. This looks like line 2, a left to right declining line. That is why our slope is negative. That's why our slope is negative. a look at one more example. So we know that graphs aren't always pretty, that graphs are number lines on top of one another, and sometimes those number lines include decimals. So you've been given another line, L, that contains point P and point R, and I want to know, what is the slope of this line? How do I get from point P to point R? All right. I see that I'm going to need to, now as I'm rising, my increments, my values are different. So every time I move up, I'm moving up a half. So instead of counting by ones, I'm going to count in halves. So I'm going to need to move up 1/2, another half, which is a full 1, and another half. So I'm going to need to move up 1.5 units. All right, so I've moved up 1.5 units, and I want to move until I'm directly at point R. So when I move over to the right one, I'm just at a -1/2, but I'm not on the y-axis like point R is. So I want to move to the right one more time. So I'm moving to the right 1 unit. This 2 halves gives a whole. Then I use this number to create my ratio for slope. Slope is going to be equal to 1/2 over 1, or just 1/2. This looks different than how we've written slope up until this point. We want to be consistent. We want to write slope as a fraction as often as possible. How can we turn the decimal 1.5 into a fraction? Yeah, it's going to be an improper fraction. Slope is actually going to be 3/2. Because there are 1.5 of 2 that goes into 3. Mark that slope to say we are done. All right, so I've done enough of examples talking at you. Now I want to see what you can actually do on your own. All right, here are exercises 1 through 6. Let's go ahead and get started if needed. Ask me for a piece of computer paper like we used in Module 2, a transparency. If you need help moving from point P to point R, but you want to tell me, what is the slope of each non-vertical line? The slope of this line, M equals 4. Number 2, what is the slope of this non-vertical line? I want to move from point P to point R. Slope equals 3. Question 3, which of the lines in exercises 1 and 2 is steeper? Let's compare the slope of each of their lines. Is there a relationship between the steepness of this slope? When I go back to exercises 1 and 2, the graph in exercise 1 seems a little steeper. And then I look at the slopes, and I see that graph 1 has a greater slope. So the greater the slope, the steeper the line. Therefore, graph A is steeper. Pick up with question number 4. What is the slope of this non-vertical line? Our directions have changed, okay? So this is no longer left to right inclining like the previous examples. This is left to right declining. So I know I'm going to have a negative slope. The slope is actually going to be equal to -1. Look at number 5. What is the slope of this non-vertical line? Slope is also going to be negative. Slope is going to be -4. Example 6. What is the slope of this non-vertical line? I want to move from point P to point R. Slope is 0. For me to get from point P to point R, I don't need to go up anywhere. And I do need to go to the right. So when I go up, nothing, and I move to the right, 1, 2, 3, I'm dividing 0 by 3. Anything divided, 0 divided by 3, 0 divided by anything is 0. The slope is 0. So let's take a look and let's use example 6 to teach just a little more before we wrap some things up. When we began, we said we wanted to define slope in a way so that horizontal lines, okay, not vertical lines, have a slope of 0. What do you notice about exercise 6? Should have noticed that the slope of the horizontal line was 0, which is exactly what we wanted it to be. In exercise 3, you were asked to compare the steepness of the graphs of two lines and then compare their slopes. What did you notice about the graphs in exercise 1 and 2? You should have noticed that the steeper the line, the greater the number the slope was. Does this same relationship exist for negative slopes? So let's look now at example 4 and example 5. Yeah, there's a similar relationship, but you should know that in exercise 5, the steeper slope is negative 4. So the bigger the negative, the steeper the slope. When slopes are negative, it is actually the smaller number that has more steepness. I'm sorry, Mr. Matthews said that wrong. When slope is negative, let's write that down. When slope is negative, the smaller number is steeper. The easiest way is to just compare the absolute values of the slope. That way you can always say the steeper the line, the greater the absolute value. So if we're looking specifically at number 4 and number 5, in number 4, our slope was -1. And equal -1. Let's take the absolute value. Remember, we use these lines to make negatives be positive, right? So I want to take the absolute value of -1, which is 1. Then for number 5, slope equal -4. We want to take the absolute value, -4, which is 4. Now we're comparing 1 to 4. And we know that 1 is less than 4. So we do still agree that graph 5 had the steeper slope. The graph 5 had the steeper slope. We do all of this to begin to create a story, So let's take it back to lesson 11 before the break. We talked about Pauline mowing a lawn. We created this table, we filled in this table, and we said that Pauline could mow a 35 square foot lawn in 2.5 minutes. We wanted to know if Pauline mowed at a constant rate, how many lawns did she mow in a certain amount of time. So we filled in these values. We created our 2-variable equation in y and t, and we found that in 0 minutes she mowed 0 lawns, and in 1 minute she could mow 14 square feet, and in 2 minutes 28 square feet, 3 minutes 42 square feet, and 4 minutes 56 square feet. Now, if we assume that the points, these points T and Y, could be put on a graph, which they can, that graph will look like this. I'll zoom in on that graph. And you should see that those graphs make a line, letting us know that this is, in fact, a linear equation. And we want to find the slope of this line. We could use our given points, our given information. So I'm just going to pick our simplest points. Let's start from the origin. How do I move from point P to her very first point? What would that rate of change look like? Be sure to use the numbers on the axis to help you out. All right, so she is going to need to go up, not fully to 15. She's actually only going to go up 14. So we're going to go up 14. Then she's going to need to move to the right 1. I remember we use those numbers to help us find our slope. So if I'm moving up 14 into the right 1, that means slope is going to be 14. What's the unit rate of mowing the lawn? Yeah, Pauline's unit rate is 14 square feet per minute. Okay, and that agrees with what we put in our table. Okay, at 1 unit in 1 minute, Pauline would mow 14 square feet. When we graph proportional relationships, the unit rate is interpreted as the slope of a line. So in a table, slope is when t is 1 minute. Let's wrap some things up. Locate your summary page to help you answer your final few questions before you move into your exit ticket and some independent practice. All right. Slope is a number that can be used to describe the what of a line in a coordinate plane. The steepness of a line in a coordinate plane. Lines in a coordinate plane that are left to right inclining are said to have a what type of slope? I'll zoom in on a line that is left to right inclining. A what type of slope? A positive slope. Lines in a coordinate plane that are left to right declining are said to have a what type of slope? A negative slope. A negative slope. And then last thing, when we're determining the slope of a horizontal line, if you're looking at a horizontal line, what would the slope of a horizontal line be? Great. Please go ahead and turn in your exit ticket to your teacher and get started on your independent practice. If your directions are differing at the end, that's great, but be sure that you have completed your packet and go back to watch anything that you need.